Welcome to section 931. Now we've already talked about adding polynomials, subtracting polynomials, multiplying polynomials, and now we're going to talk about dividing polynomials. Now, think about long division. So when we have our long division, let's say we're dividing 157 by 2. So if you remember back to long division, 2 does not go into 1, but 2 does go into 15 7 times. So the 7 goes on top. You multiply 7 times 2 is 14, and with long division you subtract. 15 minus 14 is 1. 2 does not go into 1, so we bring down the 7 next. 2 goes into 17 8 times. 8 times 2 is 16, that goes underneath. And once again, with long division, we subtract. 17 minus 16 is 1. 2 does not go into 1. And now there's no more numbers we can bring down. So what we're going to do is we'd either write 78, and that 1 is our remainder. Now with that, we would write 78, and the remainder we would write as 1, the remainder, over our divisor, in this case, is 2. And that's what we're going to be seeing when we do long division with polynomials. So what we're going to do is we're going to be dividing. So underneath our division, 3x to the fourth minus 5x cubed. Now I'm missing an x squared, so I need a placeholder. So plus 0x squared plus 4x minus 6. And I'm dividing by x squared minus 3x plus 5. That goes on the outside. You want to write as carefully as possible. There's a lot of numbers here. All I care about is the first number on the outside and on the inside. To get x squared to become an x to the fourth, I have to multiply by 3x squared. I'm dividing by a trinomial, so I'm going to count over 3 places, and my 3x squared goes on top. Now, we distribute the 3x squared to everything here. So 3x squared times x squared is 3x to the fourth. 3x squared times negative 3x is negative 9x cubed. 3x squared times 5 is plus 15x squared. Do you see how everything's lined up? That's what we want. Now, just like we did with our previous problem, with long division, we subtract. But in this case, we're subtracting the entire polynomial. And in order to subtract properly, distribute the negative. Change every single sign. Every single sign changes. And now we add the two together. 3x to the fourth plus negative 3x to the fourth, they cancel. Negative 5x cubed plus 9x cubed is 4x cubed. 0x squared plus negative 15x squared is negative 15x squared. Now we bring down the next term. I'm going to bring down my positive 4x. And we do the same thing again. There's a lot of numbers. All we care about is the first terms. I need to change x squared to a 4x cubed. To do that, I'm going to multiply by a positive 4x. Notice how my x's are all lined up. Distribute the 4x. 4x cubed minus 12x squared plus 20x. Remember, with long division, we subtract. In order to subtract properly, distribute the negative. Change every single sign. Now add 4x cubed plus negative 4x cubed. They cancel. Negative 15x squared plus 12x squared is a negative 3x squared. 4x plus negative 20x is negative 16x. And then bring down the minus 6. Almost done. I need my x squared to become a negative 3x squared, so I'm going to multiply by negative 3. So the negative 3 goes on top, and distribute the negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 3x is plus 9x. Negative 3 times 5 is negative 15. Remember, with long division, we subtract the polynomial, so distribute the negative. Change every single sign. When we add the negative 3x squared and the positive 3x squared, they cancel. Negative 16x and negative 9x is negative 25x. And negative 6 plus 15 is a positive 9. There's no more numbers to bring down, so that negative 25x plus 9 is our remainder. So the way we would write our answer is our quotient, what we get up top. 3x squared plus 4x minus 3, and we're remainder. For these, we add the remainder. So in this case, we're adding negative 25x plus 9 over our divisor, x squared minus 3x plus 5. That's our answer from the long division. I know it looks weird to put that plus negative 25x plus 9, but think about that remainder being that additional piece left over. That's how I always remember to put a plus. It's that additional adding part outside. Let's do another long division. So this time we have underneath x cubed minus x squared plus 4x minus 10. Nothing was missing. We didn't need any placeholders. And on the outside are x plus 2. A lot of different numbers here to look at. All I care about is the first terms, x and x cubed. To get x to become an x cubed, I'm going to multiply by x squared. I'm dividing by a binomial. I count over 2 places. You'll see the x squareds are on top of each other. Distribute the x squared. X squared times x is x cubed. X squared times 2 is plus 2x squared. With long division, we're subtracting. Change every single sign. Now we add up the columns. X cubed plus negative x cubed, they cancel. Negative x squared plus negative 2x squared is negative 3x squared. Bring down the 4x. Now I need my x to become a negative 3x squared. So to get that, I need to multiply by negative 3x. Negative 3x times x is negative 3x squared. Negative 3x times 2 is negative 6x. Once again, long division, we subtract the polynomial, so we want to change every single sign. So when I add up, my x squareds cancel, and I'm left with 10x, and now I bring down my negative 10. Once again, we're focusing on just the first term. X to 10x, we're going to multiply by a positive 10. When I distribute the 10, I get 10x plus 20. With long division, we subtract the entire polynomial, so change every single sign. When I add up the x's, they cancel. Negative 10 plus negative 20 is negative 30. There's nothing else to bring down. That negative 30 is my remainder. So my answer here, my quotient, x squared minus 3x plus 10 plus my remainder, plus the negative 30 over x plus 2. We're adding that remainder over our divisor of x plus 2. Let's do another one. Problem number 3. Another division problem. So 7x cubed plus 11x squared plus 7x plus 5. No terms were missing. We didn't need any placeholders on the inside. But on the outside, I have an x squared and a 1. So what I'm going to do is I'm going to put x squared plus 0x. I'm going to put my placeholder there plus 1. That just helps me keep everything in line. Now, once again, you just focus on the first terms. X squared to a 7x cubed, then multiply by a 7x. I'm dividing by a trinomial. I count over 3 places, and you can see my x's are lined up, my x to the first. Distribute my 7x, I get 7x cubed. I get a 0x squared, and I get a plus 7x. Now, with long division, we're subtracting. To subtract properly, distribute the negative, change all of the signs. So when I add them up, my x cubes cancel. 11x squared plus 0x squared is 11x squared. And now my x's cancel, so I'm going to put as a placeholder a plus 0x. And then bring down the 5. That is there just as a placeholder so I can keep everything in order. Now to get an x squared to an 11x squared, I'm going to multiply by a positive 11. So when I distribute, I get 11x squared plus 0x plus 11. Now we're subtracting. We distribute the negative. Change every single sign. The x squareds cancel. Don't have to worry about the x's anymore. And 5 plus negative 11 is negative 6. That's my remainder. So what I get is 7x plus 11 plus my remainder of negative 6 over, and now we can just write x squared plus 1. I don't need the placeholder anymore. And there's our answer from our division. Now, long division is annoying, as you can see. There's a lot of places to make mistakes with signs. What we have is we have a special case, and when we're dividing by a binomial of degree 1, we can use what's called synthetic division. And this only works with a binomial of degree 1 that we're dividing by. So we could have only used this on problem number 2. None of the other ones are binomials of degree 1. So it only worked for one of the three. So that's why we have to have long division, because synthetic division doesn't always work. Now, here's how synthetic division works. What you do, we draw, I call it a box even though it's like a big L, and we put our coefficients. For x cubed, my coefficient is a 1. X squared is missing, so I need a placeholder of 0. X to the first, the coefficient is negative 4, and our constant, our coefficient is 6. Now that goes on the inside. On the outside, set the divisor. Set x plus 3 equal to 0, and you get x equals negative 3. That's what goes on the outside. Now, what you do is you bring down the first number. You bring down the 1 to the bottom. And you multiply by what's on the outside. Negative 3 times 1 is negative 3. Add. 0 plus negative 3 is negative 3. Now we multiply again. Negative 3 times negative 3 is a positive 9. And you add that column. Negative 4 plus 9 is 5. Multiply again. Negative 3 times 5 is negative 15. And when you add, you get a 9. So what that gives us is that this number at the bottom, the degree goes down by 1. So since it was x cubed up top, here's our coefficient for x squared. Here's our coefficient for x. Here's our constant, and then number at the end is our remainder. So what we get from our synthetic division is x squared minus 3x plus 5 plus our remainder of 9 over our divisor, which is the whole thing, x plus 3. That's our answer from synthetic division. We'll be doing a lot of synthetic division in the rest of this chapter. Let's do another one. So once again, draw our box, our big L, and we want to make sure we put our coefficients. So for x to the 4th, our coefficient is 1. X cubed, our coefficient is negative 5. X squared, we have a negative 8. X to the 1st is a 13. And our constant is negative 12. There was nothing missing, so we didn't need any placeholders of 0. Then, to see what's on the outside, set x minus 6 equal to 0, and you get x equals 6. So here we bring down the 1, and now we multiply. 6 times 1 is 6. Add the column. Negative 5 plus 6 is 1. 6 times 1 is 8. Add the column, negative 8 plus 6 is negative 2. We multiply, 6 times negative 2 is negative 12. Add the column, we get a 1. 6 times 1 is 6, and we add the column, we get a negative 6 at the end. So remember, our degree goes down by 1 from the top to the bottom. So those 1 here is the coefficient for x cubed, x squared, x to the first, our constant, and our remainder. So what we get from our synthetic division is x cubed plus x squared minus 2x plus 1 plus our remainder of negative 6 over our divisor of x minus 6. That's the same answer you would get with long division, but it's much quicker. And keep in mind that only works when you're dividing by a binomial of degree 1, like we did in those two problems. All right, I will see you in the next video to talk more about how we can use synthetic division in other ways. Thank you.